Hello, welcome everyone to this new video of Ubiquiti. My name is Ronald Rodriguez, Pre-Sales Engineer in Incomex for Ubiquiti. Today, we are going to talk about the new features about UISP products, and we are going to do a little lab about Wi-Fi 5 and Wi-Fi 6 technology. But what is UISP? UISP is a network management software that allows us to manage and configure a network. Among its functions, we can do monitoring, manage devices such as CPS, switches, routers, and GPON, real-time monitoring, receive alerts, perform firmware updates, and manage large networks from a centralized management. In addition, it has an intuitive interface that facilitates network maintenance. UISP has two modules, Network and CRM. Network is all about equipment configuration and network management, and CRM is customer management, billing, etc. Here we can see the families that can be handled with UISP, like UFiber, AirMax, RFiber, LTU, and of course UISP. It is an ecosystem similar to UniFi, but orientated to ISPs. Let's see some UFiber products. Here we have OLT4, OLT8, and the new brand OLT XGS. Here we have a comparative table of the mentioned products. Claim capacity, uplink and OLT ports, power method, and PON modules. Now, here we have some models in UFiber. Wi-Fi 6 is one of the latest wireless networking standards. It offers greater efficiency and speed in data transmission. Here are some features about Wi-Fi 6. Higher speed, higher spectral efficiency, latency improvements, greater security with WPA3, and the TWT power saving mode. This helps the network to be active when requested, and when not, remain in passive mode. Now we are going to talk about UF-DMA. Basically, it was designed to overcome the interference between the receiver and the sender. For example, let's say these are lanes. For example, let's say these are lanes and users want to go to a destination. So, user 1 take the first lane, user 2 take the second lane, and so on. In summary, what does UF-DMA do? Instead of taking each user through each lane, it takes all users through a single lane at time intervals. And with this, we save 75% on CPU, which allows Wi-Fi 6 to take advantage of the frequency and reduce interference and thus obtain improvement when delivering bandwidth to users. Now, we are going to start with the lab. We'll go over the UISP console configuration a bit, user assignments, and finally, the Wi-Fi 5 versus Wi-Fi 6 speed test using the iPerf tool. This is the interface of the UISP console. It has two 10 GB SVP ports and 8 GB port for LAN. Here I show you the devices. We have the UIPS console and the OLT. Here we enter the OLT configuration and observe its configuration. We have configured the port using a 10 GB DAC cable for the connection of the UISP to the OLT. We can see the temperatures, ports used, management of UFiber devices, and services. We assign these users to a node. What will be the structure that UISP has in topology? Here, I have the router as a gateway. In the same node, I have the OLT connected, and I reach a client, in this case, Walmart. Once the device is assigned to a client, we can manage it. And from a single place, we can see the user connections, the topology, the map, etc. This is where I live, and I generate the coordinates of the UISP console and the devices in Walmart. Here, we can see more details of the wireless or network configuration. Here, you can assign VLANs, configure the speed of the ports, activate limits, services and system configurations, devices, logs, changes, updated, connection status, and disconnected of equipment, traffic statics, and much more. Now, in the lab settings, I have the Wi-Fi 6 ONU and I have the UAP Flex that is working on an 80 MHz channel. I have the UISP console to which I can put the name I want. For example, sounds, building names, site, characteristics, etc. Here I have two iPerf serve running on different ports on my computer, port 5201 and port 5202. Since we are going to test the connection from my cell phone to the computer, going through the Wi-Fi and USB equipment, I have two SSIDs, one from the Wi-Fi 6 ONU and another from the UAP Flex. On the right server port 5202 is my Wi-Fi 6 connection, and on the left side server 5201 is going to be my Wi-Fi 5 server. We are going to connect the cell phone to the SSID of the Wi-Fi 5 network and perform the test. Now, we're waiting a little bit. And then we have a time window that takes 10 seconds to download, which gives us the information of a bandwidth of 264 megabytes per second and with a data transfer of 350 megabits. Now, we are going to connect to the other SSID of the Wi-Fi 6 network and run that same test. Again, in 10 seconds download window, it gives us information of a bandwidth of 292 megabytes per second and a data transfer of 348 megabits, which we can deduce that the transfer rate and bandwidth in Wi-Fi 6 is considerably better. We have a greater amount of traffic sent and with a higher speed. There were more packets sent on Wi-Fi 6 than Wi-Fi 5. This is a controlled environment where we are close to the products because these products are in beta. There are restrictions that cannot be handled at the moment. We also run saturation tests on both networks where Wi-Fi 6 performs better on transfer and speed with less interference. This is basically what we wanted to show you what Wi-Fi 6 is capable of in the UISP family. Thank you very much for watching this video and we hope to see you soon. Bye bye.